Okay, now we can now apply the formula that the period of oscillation and frequency of oscillation. Remember, we have derived the time period of oscillation and frequency of oscillation. Now, I want to now apply that formula now to solve this question. We want to apply the formula to solve this question. So, what is the period and frequency of a simple pendulum that is 70 cm long on the Earth and on the Moon? Now, to solve this, it is quite simple. To solve this very one, it is quite simple. Now, we are looking at the case of the Earth. And the formula for time period of oscillation is T equal to 2 pi the square root of L over G. And when you have G, is simply the acceleration due to gravity. But we are looking at the case of the Earth, meaning therefore the acceleration due to gravity at the surface of the Earth is going to be 9, which is approximately 9.8 meter per second square or 10 meter per second square. 10 meter per second square. Either it's in 9.8 or 10 meter per second square. Can make use of any of the value, but I will be using 9.8. I will be using 9.8 to solve. I will be using 9.8 to solve. Now, solving this very one, applying it here, we are going to have a T equal 2 times 22 over 7, and we get the square root. And we don't work with in terms of the length of the pendulum. We were given 70 cm, and we don't work with cm. We need to convert it. Therefore, it becomes 0.70. 0.70. Please, I believe you know how to do the conversion. 0.70. Okay. 0.70. Okay. All over 9.8. All over 9.8. Remember, we have G to be 9.8. I already given you before. This one is going to be what? 9.8. And this one is 0.70. Okay, now dividing it, let us see what happens. I want to divide. This one is 44 over 7. Now let us now divide this very one. I want to divide this very one. Dividing it with the calculator. Okay. Okay, we have, using calculator, we have 0.7, that's 0.071714285. This is what we have here, 85, getting to use this one to divide this. Now, we also get the square root, and just get the square root of this, multiply by this, divide by 7. I want to go walk it straight, and put my answer there. Okay, with the calculator, let us see what happens. Okay, this is what I obtained. Mean that I have obtained this value approximately 1.62. Yeah, this is what I have. Okay, 68, not 2. On the calculator is 1.68. That to 2 decimal place. 1.68 seconds. 1.68 seconds. That is what I have. And it's the period of oscillation, the time period of oscillation is approximately 1.68 seconds. Okay, let us now see the one of the frequency. Remember that the frequency is simply the reciprocal of the period. Therefore, my F becomes the inverse, taking the inverse of the formula of the period, this one, and also the square root will be. Now let's also take the inverse of this, become G, here becomes G over L. Okay. Now, when you do that, you want to substitute, this one becomes 2 times 22 over 7, and then we have the square root. What is the G? G is 9.8, and we have our L 0.70 or 0.7. Okay, that's what we have there. Now, in this case now, I will have to divide this very one. I will have to divide. When you divide, you are going to be having this one going to turn. Becomes 7 over 1, that's 44, 7 over 44. And now when you divide here, you're going to be having 14. Just do it. Use your calculator and do that. You will have 14. Okay. Now, okay, I need to still do something here. Again there. Now let us see what will happen. There. Okay, let us see what will happen there. Meaning we need to get the square root of 14 and multiply by 7. We multiply by 7 and divide by 44. Now from the calculator, let us see what will happen. Okay, this is what we have here. Mean that we're going to have our f approximately from the calculator we have 0.6 to 1 decimal place hertz. 1 point, that's 0.6 hertz. That is for the frequency. Now this one is at the earth's surface. Okay, what about the one for the moon? Say we should also get the one of the moon. We should also get the one of the moon. Now getting the one of the moon, let us see what happened there. You mean that for the one of the moon, let us see what happened. The one of the moon. You mean that our t, we can also take our t to be, we can also use the same formula, which is this very one L by G. Okay, now t now becomes equals 2 times 22 over 7 times what the length still remains 0.70. Okay, all over. Okay, what do we have there? All over G. And what is G there? For the one at the moon, the one on the moon, it means that for the G will be, we are going to have 1.62. Please, now go back. We have done that one before. We have done it before. I've taught you how to derive G at the gravitational, there is acceleration due to gravity at the surface of the moon. We have done it before. It's simply 1.62. 1.62. It's simply 1.62. 1.62 meter per second square. Now, with this, we are going to have 44 over 7 times. Divide this very one. Let us use the calculator to work that very one and see what we are going to obtain at the end using the calculator to solve that. We are having a, okay, dividing this one, we have from the calculator here, we have 0.43209876. This is what we have here using the calculator. Now, what can we do again? We have to now get the square root. Let us get the square root. Let us get the square root of that number. Okay, now we are going to just go straight and we'll walk it straight because there is no time. I need to just walk it straight. Let me go straight and get the square root and multiply by 44 divided by 7. Let me do that. Okay, from what I have here, it means that the time period of oscillation will be approximately, for the calculator, we are having 4.14 seconds. 4.14 seconds. That is what I have there. Okay, now look at the other one, which is the we also determine the frequency as well. Remember, I told that frequency is the inverse of the period. The inverse of the period. Okay, I can just go straight and say 1 divided 4 points. I don't use the calculator. I can just I don't use the formula. The formula is very one. I don't use this one. I can go straight. I'll work it and I will have 1 over 4.14. Therefore, okay, let us see from the calculator. Let us see what happened. Let us see what happened. From the calculator, I want to see the value there. Okay. Okay, what I have here is approximately 0.2 hertz. 0.2 hertz. This is what I have. 0.2 hertz. You can also use your calculator to confirm that. Therefore, we are going to have this value. Thank you for joining me on this platform. I think we can stop here. We can just stop here. We already calculated the period and frequency on the Earth and on the Moon. Can you see there? You know that the G, which has the acceleration due to gravity at the surface of the Earth, is 9.8, while the one at the surface of the Moon is 1.62. With that, we already applied our formula. We already applied it, and we have gotten the answer. Thank you for joining me once again. All the best. God bless you.